So my name is Jacob Valenzuela, and I research 4 projects, mainly one that focuses on how do diatoms respond to climate change. That's a very important question since diatoms, which are phytoplankton in the oceans, and they account for 20% of the oxygen production in the atmosphere. So they're going to be major players in the carbon and oxygen and nitrogen cycles in the future, and we want to know how they're going to respond based on the climate change. So with climate change, you're going to have an increase in CO2. The CO2 will dissolve into the oceans, and that'll drop the pH down. So we're going to have an acidification of the oceans. How will the diatoms respond? So we use systems biology to kind of test those parameters on these diatoms, and we can then make predictions on how they'll respond in the future. Right now what we're seeing is a lot of these diatoms will actually do better, but what that means is there's going to be a lot of ecosystem shifts as we go forward. So as the diatoms do better, they're going to outcompete some other organisms, and we're trying to figure out what that consequence will be. So that's one of my main projects. The other one is kind of to mitigate climate change, where we look at microalgae, specifically Chlamydomonas, which is a green microalgae, and we grow them to make biofuel. So when we think of petroleum that comes out of the ground, that we pump out of the ground, we burn as fossil fuel, it actually is ancient oceans of phytoplankton that lived, died, got covered by silt, and over millennia got converted into petroleum. So what we would like to do is actually do that in contemporary times. So if you grow the algae, you starve them, they will actually make a lot of oil. Then you can harvest that oil and turn that into biofuel. And what we're doing there is using systems biology again to actually make it more efficient. And so what we're trying to do is re-engineer the organism to make more biofuel. The more it can make in a short amount of time, the more profitable it'll be, the less resources it'll take to actually make it. So that's another area of research that I'm focused on. The third one actually has to do with terrestrial microbes. So there's a lot of contaminated sites in the US and abroad where major projects were going on, where you have radioactive pollution, you have heavy metal pollution, those kinds of sites, and we want to be able to remediate them. And one of the main ways we can do that is actually use the microbiology that's in those areas. So we study how those microbiomes in those contaminated sites actually function, exist, and thrive in those areas, and hopefully we can take advantage of that and bioremediate those areas so that they're no longer contaminated. So that's another project I'm working on. The fourth one, some people don't consider a project, but I do. It's a main focus for me, and that's education. So every year since I was in grad school, I always make sure I take on some kind of undergraduate intern or a high school intern and kind of teach them what it is to be a scientist. The reason for that is near and dear to me is because it kind of breaks down stereotypes of what a scientist is. And one of the main things that I see coming from students is there's a lack of confidence, that they don't think they can actually be a scientist. And one of the reasons is they don't actually know what a scientist is. So when I work with them, they start to understand there's no real big difference between what a scientist is and an everyday person. And so by understanding that, it gives them the confidence they need to actually go out and do it. And so that's a really big focus for me, to actually give those students authentic research experience, help them any way I can from either applying for college or applying for graduate schools. But the main thing for me is to instill confidence in them. So that's the fourth project. So what we like to do is work with smart people. So that involves finding collaborations, asking creative questions, trying to solve these complex issues. To do that, we team up with scientists from across the country. We have collaborators at the University of Washington. We have collaborators in California. There's collaborators all over the country, and the point of that is you need different perspectives to solve these complex problems. I'm a biochemist by trade, but sometimes the problem might not be solved biochemically. It might be solved by thinking about how electrical currents flow through a network. And so we work with those kinds of people and other people like that. So, you know, these problems, they're not solvable by one person. You have to work in a team. So that's what we do. The other thing that we do is because we're trying to test what will happen in the environment, we sometimes need to bring the environment inside to the institute. And so I set up a lot of reactors to grow the algae or grow the diatoms or grow the microbes. So we have to kind of mimic what they'd be experiencing out in the environment. And that requires a lot of kind of ingenuity, problem solving, creativity to actually mimic those kinds of environments. So that's a big part of what we do. The other thing that we do that's really important is talking about what you do. So you can get, as a scientist, you can get kind of stuck in a loop sometimes, but by bringing in different perspectives, it helps you get out of that loop, and they can actually solve some of these problems. So that's how we kind of address these issues. So the one thing that ISB does really, really well is it gives you freedom to do what you want, as long as you have a good direction. So in other institutions, sometimes you're kind of working on one problem, and that's what you're working on. With ISB, there's a lot of degrees of freedom. If I want to try something, if I have a creative solution for something else, I have the ability to go and do that. If I want to work with a specific person or a different collaborator, I'm totally encouraged to go out and reach out to them. And vice versa. If someone wants to work with us, we kind of build the relationship. So ISB is really great at that, at fostering that creativity and that interaction. And that's kind of the basis for systems biology, is interdisciplinary research, that not one discipline is going to solve these problems. It's going to take a conglomerate of different perspectives to solve these problems, and that's what ISB fosters here. So that's one aspect. The other thing is the people you work with here. You find that we're very diverse, a lot of backgrounds, whether it's ethnicity, whether it's religion, whether it's how they grew up, where they grew up, all kinds of different backgrounds, and that helps feed into the creativity that we foster here. And that's probably the best day-to-day part of working at ISB, is the people you work with.